Welcome everyone. Welcome to the second lecture of this revision class. So we are revising electronics from 7:30 to 9 p.m. daily. So what is going to happen today is yesterday what we did is we did the basic electronic circuits in which only resistor was there. But today we are going to focus on a capacitor circuits. The circuits which also involve capacitors. How to solve such problems. Okay. So basically this topic is important for two exams. Number one is JEST and number two is JAM. As such, you say that okay, this topic will be connected in operational amplifiers for CSIR net and gate, but you cannot expect the direct question in net and gate. They can ask, they might have asked one question maybe, but this is not a very important topic for gate and net. But this is very important for basic understanding of electronics. So if you go operational amplifier and then they add capacitor, then you have no idea what how does capacitor works. Okay? So you cannot directly jump to the gate net syllabus without covering this fundamental. Okay? So yes, yesterday's lecture you saw that the question was there in net also and other exams also. But today's questions are basically from JEST and JAM. Okay? So let's begin. So what are we going to do? Capacitor. So let's understand capacitor. How does the capacitor behaves in a circuit? The capacitor has two categories. Number one is how does a capacitor is made? How do you find the capacitance as such? That was a class 12 syllabus. We don't need that. We don't need how to understand capacitor, how to make the capacitances, parallel plate capacitor, and so on. That is not our concern right now. Our concern is when the capacitor is added in the circuit, how does the capacitor behaves? How to find voltages, currents, charges, and so on. Okay, so we will begin with the question, but before we jump to the problem, I want to explain you the basics of this topic. So we are going to cover the behavior of capacitors, the behavior of capacitor in a DC source. DC source means direct current, which basically means battery. So whenever you have a battery, you have a direct current. The current is not changing. The voltage of a battery is not changing. So the source that you have is a DC source. Okay. One thing that you should always remember is a capacitor is someone who hates constant and it loves change. So capacitor do not like things to be constant. Capacitor likes to have the changes. So capacitor wants ki changes should happen all the time. So that is the one line statement you should always remember. Capacitor hates constant and capacitor loves change. Okay. So let me show you one circuit which is basically known as RC circuit. Basically resistor capacitor circuit. This is the best circuit to understand how does the capacitor behaves. Now someone can ask me, sir, why you have added the resistor? There was a capacitor already, so why you added resistor? So resistor is not added by me. Every circuit has some sort of resistance. So I can never ignore resistance. So I have to include, basically, I have given the symbol resistance here. Because resistance was always there in a circuit. So I cannot avoid it. So I cannot just say, okay, I have connected battery directly to capacitor. How will I do that? Whenever the currents flow, whenever the batteries are applied, resistance comes automatically. Okay? So here you can see there is RC circuit. Basically, R and C are in the circuit. And you have applied some battery and the voltage of this battery is V0. So three stages are important. Three stage we have to understand for this circuit. Number one stage is T equals to 0. So what do you think? At T equals to 0, the capacitor will enjoy the current or capacitor will hate the current? So the answer is capacitor will enjoy the current in the very beginning. Why? Because let's say capacitor means basically my phone's battery. There is a very small difference between a battery and a capacitor. The difference is that battery release the charge very slowly. Also, it gets charged very slowly. But capacitor gets charged very quickly and it also releases the charge very quickly. Okay? So capacitor is also a form of a battery, but it releases the charge very quickly, very rapidly. Within a fraction of a second, it will happen. Okay? So that is a point. Now, what I can get from this, three stages I need to understand. Very beginning, T equals to 0. So now when you connect the capacitor to the battery, what will happen? Capacitor will suddenly feel the current flowing through, because in the beginning there was no current, zero current, and suddenly you connected. So something changed, and capacitor loves change. So in the very beginning, capacitor will enjoy. So capacitor will think, oh, something is changing. Yeah, I'm loving it. Okay? So your phone was 0% charged. There was no current passing through it, and suddenly you connected the charger. So your battery or your capacitor will enjoy. Okay, things are changing. So it will behave like a wire. Wire means no problem at all. Wire is basically a person who do not stop the current at all. Wire is someone who allows all the current to pass. Okay? So capacitor basically behaves like a wire in the beginning. In the very beginning, at the very first instant, capacitor behaves like a wire. Okay. Now, slowly, the capacitor will start getting charged. Current is flowing. So now I am not at t equals to 0. I am at t greater than 0. So when I am at t greater than 0, so basically the capacitor is charging. So let's say your phone is charging. So when the phone is charging, the current is flowing in the circuit. So if someone asks, can DC current, basically can, when you connect the capacitor to the battery, can the current flow through the capacitor? Many people say no, that when you connect the capacitor to the battery, current does not flow through the capacitor. The answer is not true. It flows through the capacitor when it is charging. Once it is fully charged, so let's think about phone battery. So when it is charging, the capacitor is storing more and more charge, 30%, 40%, 50%, 60%. The current is flowing. Ultimately, when the capacitor is fully charged, then the current will stop flowing. So what is happening when you connect the capacitor to the battery? Charge keeps on increasing, current keeps on decreasing. Ultimately, capacitor gets fully charged, current becomes zero. Because once your phone is fully charged, you see auto cutoff happens and then your current does not flow. So that is a technicality here. So when you connect a capacitor to a battery, and resistance is obviously there in a circuit, so the charge in the capacitor keeps on increasing. Capacitor is a device which stores charge, stores energy. So its energy storage and its charge storage will keep on increasing, and its current will keep on decreasing. Okay? This will happen. So how to write the equations? So these are the two very important equations. So current is decreasing. So I equals to I naught into e की power minus t by RC. This is a formula, very important formula. If you want to understand the derivation of this formula, you can watch my lecture on RLC circuits. Okay. So that lecture is in the course which is available. So you can watch it there. But without derivation, I'm giving you this formula. The current in the capacitor is I equals to I naught e की power minus t by RC, which basically means that current is decreasing exponentially. As I told you, as the capacitor keeps on getting charged, the current keeps on decreasing exponentially, and finally the current becomes zero. When the capacitor is fully charged, current is zero. So this is your graph. Current is decreasing to zero. Okay. But the charge is increasing. So charge is increasing. So its formula is Q naught 1 minus e की power minus t by RC. So if you plot this graph, if you will plot this graph, you will get something like this. So the charge is increasing, and then it saturates. Saturates at 100%, because you cannot have more charging than 100%. So ultimately it saturates. Then its charge will not increase anymore. Okay? So the charge increase and saturates. Current decrease and becomes zero. The equation for charge is given. Equation for current is given. As you know, Q equals to CV. Okay? So if you divide charge with the C, you will get the equation for voltage. So the voltage equation is also like the charge equation. So the voltage across the capacitor also keeps on increasing, because if you are charging the capacitor, the voltage on the capacitor will also increase. Ultimately, it will become constant. Okay? So the last stage is that at time infinity, basically when the capacitor is fully charged, then the no current will pass through it, and it will behave like an open circuit. Okay? So what are the things we learned? Capacitor loves change. Capacitor hates constant. So when the capacitor is charging, current is passing through it, but the current is decreasing with time. Charge is increasing with. And in the final stage, in the equilibrium or in the steady state, or in the equilibrium or after a long time, what will happen is that capacitor will get fully charged. So its charge will be Q naught, fully charged Q naught. Q naught is equals to C into V naught. Okay, this you should know. Q naught equals to CV naught. Right, this equation everyone should know for capacitors. Q equals to CV. This is the heart of the capacitance, because as you know, V equals to IR is the heart of the electronics. Similarly, Q equals to CV is the heart of the capacitors. Okay, so Q equals to CV, so Q naught equals to CV naught. And ultimately, at the final stage, the current will become 0. So if after a long amount of time, if someone asks you, is the current passing through the capacitor? Then you say no. In the steady state, DC current cannot pass through the capacitor. That is why we say that capacitor blocks DC. But this blocking will happen once the steady state has been achieved, once you are in a steady state. But while charging the capacitor, this thing is not true. Capacitor do not block DC in that case. In that case, the current can flow. Okay, so that is a thing that you should understand. Yes, any doubt in this? And I would like you to write these 3 formulas, everyone, on your notebook, because this will help us in the problems. Okay. Yes, anyone wants to ask any question here till this point? Is it clear? Am I able to satisfy your physics intuition? So with this much theory, I think we can now solve our problem. Okay. So this was the problem given to me in the JEST examination. So the question is simple. They are saying that capacitor C is connected to the battery V naught. Okay, so there is one battery, there is one capacitor, and the circuit has some resistances. So there are 3 resistances. That makes our problem little difficult. So that is why that is a difference. You have covered the topic or you have not covered. So if you have covered the topic, you can solve this, because you see, yesterday's lecture will now come useful. So there are 3 resistors now. So obviously my circuit is now different from this circuit. Right, because there is not only one resistance, but there are 3 resistors. So how can I manage this change in the question? How can I work? Okay, some things have been changed, so how can I deal with it? But what is asked actually? So let's understand. So the capacitor is initially uncharged. Okay, so initially it was not charged. It means when you will connect, it will start charging up, right? That is simple. So at time t equals to 0, the switch is closed. Okay, so you close the switch. Basically, you connect the device. So then they're asking what is the voltage of the capacitor as a function of time. Okay, so this is my circuit, and I want to simplify it. Can anyone tell me what is one theorem we use to simplify the circuits? What did we learn yesterday to simplify the circuits? Yes, very first problem yesterday we covered. What we use?
Thevenin, sir.
Perfect. So now that is, you see, the whenever we need, we use Thevenin. So Thevenin is used to simplify the circuit. So basically, I will do my simplification of the circuit from here. Okay. So basically, I will remove this much part. And then I will just ask myself, how is this remaining circuit behaving? Okay. You can even remove from here. Don't worry. Okay, you have to remove from here only. That is just my choice that I'm choosing this part. So I'm just choosing AB. So I've removed this part, and later on I will connect this part back. But for now, I'm removing this part, and now I'm asking myself a question: how can I simplify the remaining circuit? So let's simplify the remaining circuit. So this is my actual circuit, and I want to find Thevenin circuit between AB. Okay, so I remove this much part, and now I want to simplify. So there are 2 things we need. One is Thevenin voltage, and one is the Thevenin resistance. Okay, very nice. So yes, so I remove this much part. This is my AB, and this is my voltage V naught. Open circuit, if you want to find basically between around this capacitor, so you open this circuit, right? You open this circuit. If you open this circuit, this will also go away. Anyway, let's not go in that detail, but I have removed this part. So that is my A, and that is now my B. How will this circuit simplifies? So basically, my first question is, what is my Thevenin voltage? Thevenin voltage means what is the voltage between this point AB? Voltage between AB is same as the voltage across R, because R is connected between AB, right? So what is the voltage across R? So your voltage is getting divided into two people. So this voltage V naught is dividing into two people. One is this R and one is this R. Since both of them are equal, half of voltage will be divided. So the voltage across this will be V naught by 2, and the voltage across this will also be V naught by 2. So what is my voltage across AB? It is V naught by 2. So I have found my Thevenin voltage straight away. Second part, what is my Thevenin resistance? So you know, in order to find Thevenin resistance, what do? Yesterday I taught you, you make this as a short circuit. So basically you convert your battery into a wire. So if you convert your battery into a wire, simple, this and this are parallel to each other. Why? You know, if this is A, this is A. If this is B, this is B. This is also B, and this is also B. Because all of them are connected by the wire, so all of them are B. So this person is connected between AB. This person is also connected between AB. Yesterday also we did the same thing. So what is the equivalent resistance? When R and R are parallel, the resistance become R by 2. Okay? So my Thevenin resistance is R by 2. My Thevenin voltage is V naught by 2. Okay? So now I understand that how does this part behaves. So this part, left part, has a voltage of V naught by 2 and has a voltage of R by 2. Overall, net effect. So that is why you see I have put a voltage V naught by 2 and a resistance R by 2. And then I bring my part and connect it with this. So you see I have now brought this part back and connected with my circuit. So I bring it back and I connect it here. Okay? Then I realized, oh, I can even make them in series. So if I make them in series, so R by 2 and R will become 3R by 2. Perfect. And this voltage is V naught by 2. Now this circuit is same as the circuit I taught you, right? Now this circuit is exactly same as this circuit. Only difference is that voltage is V naught by 2 and resistance is not R, resistance is 3R by 2. And capacitor is C का C, वो नहीं change होगा. Then I can use the direct equation कि my voltage is equals to V naught into 1 minus e की power minus t by RC. So first of all, I will put my value of voltage. Voltage is what? V naught by 2. So I put V naught by 2. Then I put my value of resistance. So if I put my value of resistance 3R by 2, so I will get this. So this is my option number D. So my option number D becomes true. So what did I use in this is, first of all, I learned is RC circuits. Okay, if I have this kind of circuit, in that kind of circuit, what happens? That is my fundament. Okay, charge will increase, so equation of charge is this. Voltage will increase, so the equation of voltage is this. Current will decrease, so the equation of current is this. But then I realized that, okay, my circuit is little bit complicated. So first of all, I make a Thevenin equivalent circuit. So I took my left hand side, and I took its Thevenin equivalent. So that was my simplified circuit. Okay? So this was my simplified circuit, and then I just put the values in my equations and I get the answer. Yes, any doubt in this problem? Okay? So if you are having a difficult time understanding, watch the previous lecture first, right? Yeah. So I think now it's a very good point that you go for a book VK Mehta. This will be your today's homework, and you can even think of it as a DPP. Go for a VK Mehta book, solve the solved problems. There are many solved problems in VK Mehta book. Okay? Yeah, I cannot share its PDF in the group because S Chand already has mentioned ki don't send the books in the group. But you can find this book somewhere, and then you can try to do the solved problems. Extremely nice book. Okay? And it has a solved problems for Thevenin circuits. So that will give you a good idea ki how to simplify the circuits using the Thevenin theorem. Because it takes some time to understand what Thevenin is actually doing. Clear? So this was the first question, and this question would have been very difficult without Thevenin because you have to do the simplification. Okay. Can I move to the second problem if everyone agrees with me? What do you say? Can we go for the next? So second problem is, now the problems will little simple. So first problem was little difficult. Now the problems are simple. The second problem is also from Jest. Let's read the problem. So they're saying that consider the following circuit in the steady state. Oh, steady state. Steady state means fully charged. Fully charged means no current will pass through the capacitor. So no current will flow here. No current will flow here. I will use the one logic and the next three problems will be solved in the same way. So understand this logic very clear. So no current is flowing here. No current is flowing here because first of all, there is a battery, which is a DC battery. And second of all, there is a steady state. Steady state means charging has been completed. So now no current will pass through the capacitor. Okay. So then they says that what is the amount of charge on 1 microfarad capacitor and 2 microfarad capacitor. So what is the charge on this and what is the charge on this? So charges will obviously be there because you see in a steady state capacitors are fully charged. So after getting fully charged, what is the charge on them? How much charge you can, what is the charge they have? That is what they're asking. That's all. Simple question. So I redraw my circuit. So this is my circuit here. It's exactly same circuit. So one thing is very clear. If they ask you charge on any capacitor in a circuit, listen to these steps very clear. If they ask you to find a charge on any capacitor, you find the voltage on it. What is the voltage on this? What is the voltage on this? What is the voltage on this? Because if you know the voltage, then charge is very easy. Q equals to CB. So if you know the voltage on 1 microfarad, you know the charge also. Okay. So first thing is clear that I want to know the voltage on this. Second question is, how can I find the voltage on this? How can I know the voltage on this? So whatever is the voltage between A and B, so between this point A and between this point B, so for example, just for a moment, let's assume the voltage between them is 10 volt. It cannot be 10 volt, but for a minute, let's assume it is 10 volt. Okay, then the voltage between these 2 points will also be 10 because both of them are parallel, right? So if this is A, then this is also A, and if this is B, this is also B. So if the voltage on 2 kilo ohm resistance is 10 volt, then voltage across this line is also 10 volt. Can anyone tell me what is the voltage across this 4? What is the voltage across this 4? Can you tell me? If the voltage is over, total voltage is 10, what is the voltage on 4? Do you need formula for that? Or the answer is very much in front of you? Anyone? Let's see how much you have understood the electronics. So what is the voltage on this 4? 6 volt. Okay, no, wrong answer. The answer is very simple. Okay, think about it. How do you find the voltage across resistor? V equals to IR. It's a very good hint. What do you think now? What do you think now? 0. Yes, 0. Why 0? Because see, there is no current which is flowing here, right? No current is flowing in the upper branch. So if no current is flowing in the upper branch, the voltage across 4 is 0. So voltage across 4 kilo ohm is 0 because voltage will come only if the current is there. V equals to IR. So in resistance, as long as no current is flowing, there is no potential. Okay? So voltage drop across this will be 0. Why will voltage drop? Because current is not there. Why will voltage drop across resistance? So it is 0. So all the 10 volt will go to this capacitor. Okay? So that is the point. So now you might have understood how to find the potential around this capacitor. This capacitor. How to find it? So first step, I will find the voltage across this resistor. इसके अराउंड वोल्टेज कितना है? सो लेट से इसके अराउंड वोल्टेज आ गया 10 वोल्ट. अगर इसके अराउंड 10 वोल्ट है तो इसके अराउंड भी 10 वोल्ट है. वोल्टेज अराउंड दिस इज आल्सो 10. But the voltage around this is 0 because current is not there. So all the voltage will go to capacitor. So इसके around voltage will directly कितना आ गया? 10. So everyone, very quickly, is this story clear? कि how I am going to find the voltage on capacitor? Is this story clear? कि कैसे मैं capacitor के ऊपर जाके voltage निकालने वाला? Yes, please. What do you think? Everyone. This point is clear. Yeah. How I'm going to find the voltage across capacitor? Okay, any doubt here? No? Yes, no, कुछ भी चलेगा. If you have anyone have a doubt, please ask very freely again. No problem. Okay, ठीक. Again, okay, again बात करते हैं. Again, someone asked again. So what I'm going to do is I'm going to find the voltage across this 2 kilo ohm. So let's say the voltage around this 2 kilo ohm comes out to be 10 volt. कैसे करूंगा वो बता. First, I will find the voltage around this 2. If the voltage around this 2 is 10 volt, then the voltage around this is also 10 volt. ठीक है? Because both of them are parallel. Now voltage around resistance is 0 because no current is flowing in this. So V equals to IR. So voltage across resistor is 0. It means all the voltage will be around the capacitor. So what will be the voltage around capacitor? 10 volt. So that is the theory. Okay. So let's now do this. So now your battery, let's say, is giving the current I. So your battery gave the current I. This current goes in this direction. And then this current straight away goes here because current cannot go in the upper branch. Current cannot go in the lower branch because it's a steady state. Current cannot pass through the capacitors. So current will straight away go and then come back. So what is the total resistance in the circuit? So first you have is a 1 kilo ohm and then you have is a 2 kilo. Okay. These two are not playing any role because current is not passing through them. So there are this 1 kilo ohm and 2 kilo ohm are in series because you see the current goes straight away and then come back. So what is the total resistance in the circuit? 3 kilo ohm. And what is the total current in the circuit? Total current in the circuit is voltage by resistance. Total voltage in the circuit is 6. Total resistance in the circuit is 3. So total 3 kilo ohm. That is why the total current in the circuit is 2 milliampere. Okay. So that thing I have identified, the total current in my circuit is 2 milliampere. So 2 milliampere current is passing through it. Okay. Now I will come back to my scenario. Okay. What is the voltage across this resistor? So voltage across resistor, you know, is IR. What is the current passing? 2 milliampere. And what is the resistance here? 2 kilo ohm. So this becomes 4 volt. It means the voltage around this resistor is 4 volt. Again, if this is 4 volt, then this is also 4 volt. Voltage here is 0. So all the 4 volt will go here. Same thing will happen below as well. So if this is 4 volt, then this is 4 volt. Voltage here is 0 because no current is passing. So all the voltage will come here, 4 volt. It means the voltage on both the capacitors is 4 volt. So voltage on both the capacitors is 4 volt. Okay. Now let's find the charge. So charge is CV. So first capacitor is 1 into 4, which is 4 microcoulomb. In the second case, charge is also CV. So second capacitor is 2 microfarad. You see, this is 2 microfarad and this is 1 microfarad. So CV, so 2 into 4, which is 8 microfarad. Okay. So first capacitor contains the charge 4 microcoulomb and second capacitor contains the charge 8 microcoulomb. Okay. So that gives you an answer. Answer is 4 and 8, which is your option number A. Clear? So I hope this is clear. Any doubt you have in this problem, please let me know. So the next problem is also very similar. Or again, it is taken from JEST. So it is being taken from the very recent years, 2020, after 2020 only. So last 4-5 years only, I'm talking about these questions. So again, the similar question, look at the circuit, very beautiful circuit. And again, you have a battery, which is 12 volt. You have a resistance 3 ohm. You have a resistance 6 ohm. You have a resistance 3 ohm. What they are asking? Again, they are asking what is the charge on the capacitor C1 and C2. Okay. Again, the very similar concept I'm going to use. What is that? Voltage. Concept of voltage. So let's do it. So one thing is very clear, since it is not mentioned, but since they are asking the charge, it means the capacitors has been fully charged. That is why they are asking the charge, right? So now we are at the end stage. When they are asking the charge in itself means that, okay, the charging has been done and now they are asking you the charge. It means we are in the steady state, although it is not directly mentioned, but it is very clear from the language of the question. Okay. If they were asking in between, then charge will change with time. But in the options, you can see the charge is not changing with time. It means you are in the steady state. Charging has been completed. So in the last step, what is the final charges we have? 100% charging में कितना charge? Done. So okay, again, so no current will pass here. So ठीक है, यहाँ से current will come I, then वो सीधा ऊपर चला जाएगा I, and then it will go here I, and then it will go here I. So do you all agree कि 6 ohm, 3 ohm and 3 ohm are in series? क्योंकि यहाँ से जो करंट निकला वही आई यहाँ से निकलेगा and वही आई यहाँ से निकलेगा, तो तीनों में से the current which is passing is exactly same. So I hope you all agree with me that the current which will pass through all three is same. It basically means that all of them are series. So the total resistance in the circuit is 3 plus 6 plus 9, which is 12 ohm. So what is the total current in the circuit? So total current, again, the same logic what I used in the last question, total voltage by total resistance. So total voltage is going to be 12 volt and total resistance is going to be 12 ohm. Right? Total voltage 12, total resistance 12. 12 by 12 gives you 1 ampere current. It means the total current which is passing in the circuit is 1 ampere. Very fine. Very fine. Very fine. Okay, again, once you know the voltage, once you know the current, you need voltage. So what is the voltage around A and B? What is the voltage around A and B? So whatever is voltage around 9, because 9 is also between A and B. So whatever is the voltage across 9 ohm, the same is the voltage across A and B. So I can find the voltage around 9. कैसे? V equals to IR. What is the current? 1. What is the resistance? 9. तो कितना voltage हो गया? 9 volt. So it means the voltage between A and B is 9. Okay. What is the net capacitance of these two? A and B के बीच में voltage तो निकल गया. A and B के बीच में voltage comes out to be 9 volt. But A and B के बीच में capacitance कितना है? So you know in capacitance rules are उल्टा of resistance. तो resistance में series में add होता है, parallel में 1 by R होता है. इन कैपेसिटर्स सीरीज में 1 by C होता है और पैरेलल में ऐड होता है, तो उल्टा हो जाता है रूल. सो सिंस ये दोनों कैपेसिटर सीरीज में है, दे बोथ आर इन सीरीज, सो व्हाट इज द नेट कैपेसिटेंस? सो 1 by C equals to 1 by C1 plus 1 by C2, और यू कैन से C equals to C1 C2 by C1 plus C2. C1 C2 करेंगे तो क्या होगा? कौन से दो कैपेसिटर है? 1 is 1 and 1 is 2, so 1 into 2 2, 1 plus 2 3. So what is the overall capacitance? 2 by 3 microfarad. That's all. So मुझे बहुत कुछ पता चल गया. I have identified a lot of things कि between A and B my capacitance is 2 by 3 and my voltage is 9 volt. So what is the charge here? Charge will be CV. तो CV करेंगे तो 2 by 3 into 9 which is 6 microcoulomb. अब दोनों पे 6 होगा ना, इस पे भी 6 microcoulomb होगा, इस पे भी 6 microcoulomb होगा, because in the series the charges are same, voltages are different. In series currents are same, voltages are different. So since both of them are in series, दोनों के ऊपर charge how much will be there? 6 and 6. So total charge on each capacitor is 6, which is your option number A. ठीक है? So the same logics are there. First, you analyze the circuit कि current where will the current pass? Okay, find the total current. Once you know the total current in the circuit, focus on your capacitor part कि okay, where your capacitors are connected, वहां पे voltage कितना है? How much is the voltage? तो A and B के बीच में उतना ही वोल्टेज होने वाला है जितना वोल्टेज 9 ओम के ऊपर होने वाला है. सो व्हाट इज द वोल्टेज अराउंड 9 ओम? वोल्टेज अराउंड 9 ओम इज 9 into करंट 9 वोल्ट. सो इनके अराउंड वोल्टेज 9 है और इसके अराउंड कैपेसिटेंस कितना है? सीरीज में फॉर्मूला लगेगा. इफ यू पुट द सीरीज फॉर्मूला इट विल बी 2 by 3. तो वोल्टेज इज देयर, कैपेसिटेंस इज देयर, चार्ज निकाल लेते हैं. Q will equals to CV, which will come out to be 6 microcoulomb. एंड सिंस बोथ ऑफ देम आर इन सीरीज, तो दोनों के ऊपर चार्ज 6 ही होगा. ठीक है? सो बिकॉज अगर पहले कैपेसिटर पे 6 माइक्रोकूलम है तो अगले पे भी 6 ही जाएगा. क्लियर? सो द आंसर इज 6 माइक्रोकूलम. सो आंसर नंबर ए इज करेक्ट. एनी डाउट यू हैव, प्लीज आस्क freely with your mind. Right? So the next problem, again similar concept, capacitor concept, same logics, everything will be same. Let's try to do it. So they say consider the circuit shown in the figure. So very beautiful circuit, very simple circuit. Is the capacitance of the capacitor E? So basically there is a battery E and then the capacitor is C and so on. Basically what they're asking, let's see. So what they're asking is what is the charge on the capacitor? That's all. They are asking what is the charge on the capacitor. Okay, same logics, everything same. If you want to know the charge on the capacitor, what do you want to know? You should know what is the voltage across this capacitor. If I know the voltage across this capacitor, then charge is very simple. Charge is CV. So again, the step is same. What is the voltage around these 2 points? What is the voltage between A and B? So let's simplify the circuit first of all. How can I simplify? Okay, let's first understand the currents. So how can I understand the currents? So let's see, these two are in series. So R and R becomes 2R. And then this 2R becomes parallel with this, right? So 2R and R are parallel. So it becomes 2R into R. 2R plus R will be 3R, which will be 2 by 3R. So this is your resistance. Okay. So that is why I have simplified these three and I have written 2R by 3. Okay. Then you have what I can. So I missed one thing. So did I miss something? Okay. How did I miss
Resistance
that?
and the correct answer.
वो
Yeah,
Resistance.
this.
diagonal rest.
Yeah, this resistor I missed. Okay, so why I got the correct answer in that case? Okay, okay. So I missed that resistor. Although okay, R is there. Okay, 2R by 3. Okay. Mm. So then this question will change. Okay, this question will basically change in this scenario. Okay, okay. So we have to do this question again in that case. So let me do this question again because I solved it. So let's paste it here. So let's solve this question. So one thing is very clear. Okay, these two are in series and then it is parallel. So what do we get? It is 2R by 3. Okay, then this is R, perfectly fine. I am happy with this. So since no current will flow from here, so let's ignore it for a minute because no current is flowing from here. Capacitor is in a steady state. Okay, and then I have this beautiful R here as well. And then I have this beautiful R here as well. That's all. And then I have this battery. Okay, and I'm calling this point as A and I'm calling this point as B. So let's find the net resistance so that I can know how much current my battery is giving. So in order to find the net current, these two are in series. This is also series. So these three people are in series with each other. So R plus 2R by 3 gives you 8R by 3. Okay. And then this 8R by 3 is in parallel with this R. Very clear. Then these 8R by 3 is in parallel with this R. Okay. So 8R by 3 is in parallel with this R. So 8R by 3 plus R. So it will give you 8R square by 3 divided by 11R by 3, which gives you 8 by 11. Okay. Something is fishy. I'm not happy with what in the direction we are going, but okay. It is 8R by 11. Okay, I don't mind. So the net resistance in this question is 8R by 11. Okay. What is the net current in the circuit? Net current is total voltage, which is E, divided by total resistance, which is 8R by 11. Perfect. Okay, this much is okay. So now the current is flowing in my circuit. And yes, okay. What I now want to know is what is the voltage between A and B? How can I find that? That is more important. How can I find what is the voltage between A and B? That is much important part to know here.
Sir,
Okay. Yes.
sir, the way you have connected the cell, the current flow, sir, isn't that opposite as shown in the diagram?
Okay. Yeah, that is okay. Current will go like this. Okay, that is okay. That is okay. Sir, series and parallel resistance is confusing. Series and parallel is confusing. बेसिक्स थोड़े से वीक है. देखिए क्या है, ये तीनों क्यू सीरीज हैं. लेट्स टॉक स्लोली. ये तीनों क्यू सीरीज हैं बिकॉज लेट्स से if some current is here, let's say here the current is I1, so the same current will be here because current I1 will go here and then take a turn. So here also the current will be I1 and here also the current will be I1. So these three become series. Okay, इन तीनों को सीरीज कर लेते हैं. सीरीज के लिए what we have to do is add them. So if I add them, I will get R plus 2R by 3, which is 8R by 3. Okay. So now let me simplify this. Instead of writing all of 3, I will just write 8R by 3. Okay, 8R by 3. Now, what will happen with this R and with this 8R by 3? Now you can clearly see this point was B, and let's say if this is C, then you can clearly see that this 8R by 3 is connected between B and C. And this R is also connected between B and C. That is why both of them are parallel. And when two people are parallel to each other, you use the formula R1 R2 by R1 plus R2. That is why I did 8R by 3 into R divided by 8R by 3 plus R, which gives me an answer of 8 by 11. Okay. So my total resistance I got, total current I got. Okay. Now let's come back to the circuit. So this was my circuit. Okay. This was my circuit. This is my R, and this is my 8R by 3. Okay. And this total is E. So voltage across these points is E. So C and B के बीच में voltage will be, what will be the voltage between B and C? E. So around the R voltage is E. Around the 8R by 3 also the voltage is E. Okay. How this 8R by 3 is made? Let's go back one step back. How is this 8R by 3 made? So 8R by 3 was made because there was this R, then there was this another R, and there was this 2R by 3, or this 2R by 3 was coming like this. So there was this 2R by 3. And this point was B, and this point was A. What I know is key C and B, this voltage is how much? E. Right? C and B के बीच में voltage is E. I want to know the voltage between A and B. I want to know the voltage between A and B. So what is the first step that I will do? What I will do is I will divide A and into two parts. One is A by B के इधर वाली side, left hand side, and one is A by B के उधर वाली side, which is right hand. ठीक है. So okay, right hand side क्या कर सकते हैं? R and 2R by 3 we can combine, because R and 2R by 3 will be series. So R and 2R by 3 I can combine, and this will become 5R by 3, just to simplify myself. So this is basically 5R by 3. So now A and B have two parts basically. One is left hand part and one is right hand part. Right hand part has a resistance 5R by 3, left hand part has a resistance R. If you go from C to B, if you go from C to B, what is the total voltage difference? Capital E. I don't want to go from C to B. I want to go from A to B. I want to know what is the voltage difference between A and B. Basically, what is the voltage difference between this side? So I will use the voltage division rule. I told you the voltage division. I want to know the voltage around 5R. I know the total voltage between C and B, but C and B is made up of two P, one R and one 5R. I only want to know the voltage around 5R because I need to know the voltage between AB. Okay? So voltage between AB will be total voltage into iska resistance, which is 5R by 3, divided by 5R by 3 plus R. Voltage is dividing between whom? Two people, this and this. Yesterday we talked about voltage division rule. The same thing. So total voltage is how much? Total voltage is E. 5R by 3 is 5R by 3, and this becomes 8R by 3, which basically means that voltage have become 5E by 8. 5E by 8. So after a long calculation, I have identified that the voltage between these 2 points is 5 by 8 into E. So this is a voltage, then what is the charge? Charge is C into V, which is 5 by 8 into C into E. Okay. So this gives you option number B as the correct answer. Okay. Now again, let me summarize this question for you. And what is the summary of this problem? They gave you the circuit and you have to play with the electronics to get an answer. And how can I play? So in order to play, one thing is that you first of all work with these three. तो ये दोनों तो series में. Why? Because if some current is here, the same current will be here. So if these two are in series, so they both are 2R. And then this 2R and this person is parallel. So 2N and R parallel, when you do it, it becomes 2R by 3. So ये तीनों मिलकर 2R by 3 बना रहे हैं. So these three combine together to give you 2R by 3. ठीक है? So that is what you see. That is what you see here. तो ये तीनों मिलकर 2R by 3 बना रहे हैं. Then you have this 1R left here. And then you also have this 1R left here. And then you have this R left here. Okay? And then this is your battery. So these three combine together to give you 8R by 3. Okay? So one 8R by 3 is here, one R is here, and then this is a battery. This point I call it as C, this point I call it as B. The voltage between C and B is E. But I don't need voltage between C and B. I need voltage between A and B. So then I divide A and B into two sections, one left hand side part of this and one right hand side part of this. Okay, so if I do that, I focus on this part. Okay, voltage around this 8R by 3 is E. वो मैंने identify कर लिया कि इसके around voltage E है. How is this 8R by 3 made? 8R by 3 was made by using this. Okay, this point is C, this point is B, and this point is A. Okay, this is how you made. C and B के बीच में voltage is E. That is why I know. I want to know voltage between A and B. और इन दोनों को अगर if I combine, this will be 5R by 3. Now my total voltage is dividing between R and 5R by 3. I need the voltage around 5R by 3. And if I use a voltage division rule, I will get the voltage 5E by 8. So the voltage around A and B is 5 by 8. Once I know the voltage between A and B, I can find the charge between on the capacitor, which is Q equals to CV. So I take C, I multiply it by V, I get the answer. Okay? So sit down with this question and you try to find out, okay, this is your circuit. How will you find the voltage between these two? That is the challenge. One is a technique that I gave you. You can even try something. Okay? Yes, any question, doubt in this? हो सकता है कि this problem you might not have understood completely, but yeah, something I can help you with, anything. So now we go for the last topic, or you can say the last thing for today. Okay, and that is going to be inductor. So sometimes you also see inductor. Once you have understood about the capacitor, shifting to inductor is a very simple thing. So inductor is something made like that, and every inductor has some self-inductance L. You don't have to go in approach how to find this L, but has some self-inductance L. How does inductor behaves? So we want to know how does my capacitor and inductor behaving in a circuit. So what an inductor do is ki inductor hates change. Inductor do not like change. If you change something from an inductor, it will not like. It is reverse of capacitor. So capacitor used to like the change, but inductor hates the change. Okay? So if the current through the inductor changes, the conductor will not like that, and it will induce some EMF to stop that current. You know Faraday voltage, Faraday induced voltage. So if you try to change the current through the inductor, how will current respond to that? So current will induce some EMF in it, voltage in it, and that voltage will try to stop the change. That is what an inductors do. So how much is the voltage which is there in an inductor? So voltage induced in an inductor is minus L into di by dt. This is an important formula. L is the inductance and di by dt is the change in current. So whenever the current changes, EMF will come. If the current is not changing, this thing will become zero. And there is a negative sign, which basically tells you that this EMF is trying to stop the change. If the current is increasing, it will try to decrease it. If the current is decreasing, it will try to increase it. So basically, it will always try to oppose the change. Okay. There is a very small difference. What will happen in an RL circuit? So now you don't have RC circuit, you have RL circuit. One is R, one is L. You connect it to the battery, and what will happen? What will happen in a capacitor? In a capacitor, charge increases, current decreases. कैपेसिटर को साइड में, लेट्स पुट कैपेसिटर साइड. नाउ लेट्स कम टू इंडक्टर. इन इंडक्टर करंट इंक्रीज, देयर इज नो क्वेश्चन ऑफ चार्ज इन दिस, सो चार्ज का तो कोई सवाल नहीं. So what will happen in an inductor? In inductor, current will not decrease with time. Instead, the current will increase with time, and ultimately it will become constant. Okay. So in the beginning, the current will increase, and then it will become constant. Because ultimately, inductor wants to bring the current to the constant value because it does not like the change. So current in this case will increase, and then it will become a constant value. And the formula in this case will become I naught 1 minus e की power minus RT by L. So basically, in the capacitor formula, you had e की power minus T by RC. In this, you have minus RT by L. Okay. So that is a formula that you have. This is also very important formula, and that is how you go from a capacitor to inductor, where I naught is basically using the Ohm's law is V naught by R. Perfect. Okay. Now what is up at t equals to 0? So now again the three behaviors. Behavior number 1, at time t equals to 0, what do you think? Inductor will enjoy or inductor will hate? Inductor will hate. Because at time t equals to 0, suddenly nothing was happening, inductor was sleeping, and all of a sudden you put a battery, so the current suddenly changes, and inductor does not like change. So in the very beginning, the current changed a lot. That is why you see the basically the voltage, you can say the change was very rapid. That is why at time t equals to 0, no current will flow. Current will flow at a later stage, but at time t equals to 0, no current will flow. And yeah, that you can check also. If you put time 0 here, e की power 0 is 1 and 1 minus 1 is 0. That is why inductor in the very beginning hates current. क्योंकि अचानक change हुआ ना. We did not give any time to inductor. After 1 millisecond, 2 millisecond, inductor will have some time to, current has to flow. Then in middle, I have given you the equation. In middle, what will happen? And then finally, when the time is infinity, then the current will become constant. Constant means now inductor has no problem. So inductor will behave like a wire. Wire means short circuit. Okay? So this behavior is completely reverse of capacitor. Capacitor was doing the reverse. Starting में it was wire and then it was open. But in this case, starting में it is open and in the end it is like a wire. That is the case. So capacitor is someone who likes change. Inductor is someone who hates change. I gave you the equation for both, and I need to solve one problem which is taken from the IIT JAM, which will help. So they are saying that current is passing through a series RL circuit. They also gave you the equation. I don't need this equation, but L is given to you as 1 millihenry. Resistance is given to you as 1 kilo ohm. EMF is given to you as 1 volt. I naught, basically they're saying at time 0 current is 0. Okay, that is okay. That is not required as such. Then they are asking what is the current at time 1 microsecond. So I will use the equation. I equals to I naught e की power minus RT by L. What is I naught? I naught is V naught by R. What is the voltage? 1 volt. What is the resistance? 1 kilo ohm. So it will give you 10 की power minus 3 because kilo is 10 की power 3 ऊपर जाके minus 3, so it will give you 1 milliampere. Then I need to know this, what is RT by L. Okay, R की value is what 1 kilo ohm, which is 10 की power 3. Time is 1 microsecond, so 10 की power minus 6, and L is 1 millihenry, so 10 की power minus 3. So this gives you 1. So this gives you 1, so you get e की power minus 1. Here you have 1, and current is 1 milliampere. So they are asking that, okay, give me the answer in 1 milliampere. So ignore this milliampere. So answer you are left with is 1 minus e की power minus 1, which is your option number C. Okay. So that is how you convert yourself from a thinking of a capacitor to a thinking of an inductor. One thing which is very important is I did not touch the AC circuits. Never I applied the AC voltage. At all the times, the voltage which I applied was purely DC. Okay. And yeah, that is all for today's lecture. Any doubt you have in today's session?